Hi, I'm Ace Beralde and I'm currently studying at Camarines Polytechnic Colleges under the College of Computer Studies, pursuing a Bachelor of Science in Information Technology. Let me ask you something. Have you ever thought, why do we need math? I mean, sure, we learn about numbers, equations, and formulas, but where do we actually use them? Today, we're going to break that down and see how mathematics is all around us, sometimes in ways we don't even realize. What is mathematics in our world? Okay, mathematics isn't just about numbers and solving problems in class. It's basically the language of the universe. It helps us measure things, understand patterns, and make sense of the world. Without math, we wouldn't have technology, buildings, or even time as we know it. For example, every time you check the time, you're using the math. When you manage your allowance or budget, your expenses, that's math. Even the technology in your phone, from games to GPS, works because of the mathematical algorithms. What is mathematics used for? Think about your favorite hobbies, whether you have sports, music, video games, or even cooking, math is involved. In basketball, for example, players use angles and timing to make the perfect shots. In musicians, they rely on rhythm and patterns, which are all based on mathematical principle. Even when cooking, you measure ingredients to make sure the dish turn out just right. And let not forget gaming developers. Use math to create graphics, physics, and AI to make games feel real. What are the benefits of learning mathematics? Okay, so math is everywhere, but why should we actually care about learning it? Well, first, it makes us better problem solvers. Life is full of challenges, and math helps us think logically and find solutions. Mechanics use math to figure out car problems. Even doctors analyze medical data to diagnose illness. Second, math sparks creatively. It's not just about strict formulas. It helps us invent and design new things. Game developers use algorithms to create realistic effects. Architects design amazing buildings using geometry. Even artists use math to create a balance and patterns in their work. And lastly, math opens up tons of career opportunities. Whether you dream of becoming an engineer, a pilot, a financial expert, or even a tech entrepreneur, math will always be part of the journey. Hi, I am James Ray Venezuela, and I'm currently studying at Camarines Polytechnic Colleges under the College of Computer Studies, pursuing bachelor's and information technology. Bakit dito? Because today we'll be discussing about Fibonacci sequence. But before we start, let's answer some few questions first. What is Fibonacci sequence? Saan sa ito ginagamit? And what are the benefits of learning about it? Malalaman natin yan mamaya. Kaya stay tuned as we explore the fascinating world of Fibonacci sequence and discover its significance. Ano nga ba ang Fibonacci sequence? The Fibonacci sequence is a mathematical pattern where each number is the sum of two preceding ones starting from 0 and 1. The sequence follows like this, and it goes on forever. Think of it like a recipe where you keep adding the last two ingredients to make something new. It appears in nature, technology, and finance. This sequence helps us understand patterns, optimize calculation, and appreciate the hidden mathematics in the world around us. Saan nga ba natin makikita ang Fibonacci sequence? You might be surprised to know that the Fibonacci sequence is everywhere. Tulad nga ng sabi ko kanina, in nature, technology, and finance. First is nature. In nature, have you ever looked at the sunflower and noticed how its seeds spirals that's Fibonacci? The same pattern appears in pine cones, shells, and even galaxies. In technology and computing, it has used algorithms for searching and sorting data efficiently. Many programming challenges also involve Fibonacci patterns. Here's some example. The Fibonacci rabbits. Imagine you start with one pair of rabbits. After a month, they mature and reproduce, creating another pair. Each new pair follows the same pattern, maturing for a month before they too start reproducing. As the months pass, the number of rabbit pairs grows in a sequence, starting from one pair, two pairs, three pairs, and five pairs, and so on. And this is the Fibonacci sequence in action. How do we calculate Fibonacci numbers? We know that the Fibonacci sequence follows the rule f sub n equal f sub n minus 1 plus f sub n minus 2. For example, we need to find the 11th Fibonacci number using this formula. Fn equal f sub n minus 1 plus f sub n minus 2, where f sub n is the Fibonacci number and f sub n minus 1 is the number before f sub n, plus f sub n minus 2 is the number before f sub n minus 1. It equals to 89. So the 11th Fibonacci number is equal to 89. Paano kung nasa gitna ang nawawala? How can we resolve it? Using this formula, f sub n minus 1 equal f sub n minus f sub n minus 2. We just need to repeat the process from the previous problem. We just need to minus the two Fibonacci numbers, which is the before and after of f sub n minus 1. What if we need to find larger Fibonacci numbers, like 30? Calculating step by step is slow. That's when we need to use the Binet's formula. What is Binet's formula? Instead of adding numbers repeatedly, Binet's formula let us find any Fibonacci numbers instantly. In summary, the Fibonacci sequence is more than just a mathematical pattern. It's a fundamental concept found in nature, technology, and even finance. Learn that it follows a simple rule. Each number is the sum of the two before it. It appears in nature, from sunflower spirals to seashells and fine bones. It has practical uses in computer science, stock market analysis, and problem solving. This sequence is not only fascinating but also essential in understanding the hidden patterns in our world. So ayan guys, and that concludes our discussion about Fibonacci sequence. We explored its definition, real-world application, and how to calculate in terms using formulas like Binet's formula for faster computations. But our journey doesn't stop here. Did you know that the Fibonacci sequence is closely connected to something even more fascinating? The golden ratio. Up next, Jordan Dre Bonganel will take us deeper into the golden ratio, its significance, and how it shaped the beauty of the world around us. So stay tuned and let's continue uncovering the wonders of mathematics.
Hi, my name is Mmw and I'm here to continue on the topic about the golden ratio. Now, the golden ratio is a special number often found in nature, art, architecture, and design due to its aesthetically pleasing proportions. Now, the golden ratio, often denoted by the Greek letter phi, is a special number that appears when two quantities have the following relationship. The ratio of the sum of the two quantities to the larger quantity is the same as the ratio of the larger quantity to the smaller one. In mathematical terms, if you have two numbers a and b, where a greater than b greater than 0, the golden ratio is defined by this equation. This means that the ratio of the whole to the larger part is the same as the ratio of the larger part to the smaller part. The value of p is approximately 1.618 and so on, and it has some interesting properties, such as the golden ratio is closely connected to the Fibonacci sequence. In the Fibonacci sequence, each number is the sum of the two preceding ones. As you progress through the sequence, the ratio of the consecutive Fibonacci numbers gets closer and closer to the golden ratio. And that's all there is to the golden ratio. Up next is Gerald Viasca with the topic about fractals and fractal geometry.
Hello everyone, my name is Tarini S. Diasca, and today we're going to explore an exciting and fascinating branch of mathematics, fractal geometry. This topic divides into the world of infinitely complex patterns where shapes repeat themselves at different scales, creating stunning intricate designs. Before we start, let's try answer this question. Number 1, can you name other natural objects that exhibit fractal patterns? Yes, you're right. Many natural objects exhibit fractal patterns, including the galaxies. The arrangement of galaxies and cosmic structures display fractal-like distribution. And number 2, how do you think fractal are used in modern technology? Yes, fractal are widely used in various technological fields such as computer graphics and animation. Fractal helps create realistic landscape, clouds, and textures in movies and video games. Now let's proceed in fractal geometry. What is fractal geometry? Did you know that fractal geometry is a branch of mathematics that studies and shape in patterns that exhibit self-similarity, meaning they look at the same at different levels of magnification? Unlike traditional Euclidean geometry, which deals with straight lines, smooth curves, and fractal geometry, focuses on irregular and fragmented shapes found in nature, such as coastline, mountains, and hills. A fractal is a geometric shape that can be split into smaller copies of itself, each resembling the whole. Those patterns can be generated using mathematical formula and are often used in computer graphics, physics, and even medical imaging. Let's give an example of a fractal. One of the most famous fractal is the Mandelbrot set. It is a mathematical set of points that when plotted creates an infinitely detailed and complex pattern. No matter how much you zoom in, you will always find smaller version of the original shape within it. Imagine a swirling, black and blue pattern with infinitely complexity. As you zoom in, you see smaller, self-repeating patterns within the main structure. The edge of the setup form intricate lightning bolts-like patterns that never end. Fractal trees are branching patterns in nature. Imagine a tree in a forest. The trunk splits into large branches, which then split into smaller branches, and then into tiny twigs. These patterns repeat indefinitely just like a fractal. Each branch is split into smaller branches. This repeating pattern is an example of how fractal appear in nature. Another example is snowflakes. Each snowflake has a unique but similar design, making it a natural fractal. We have another example, the broccoli or fractal input. Yes, even food can be a fractal. Romanesco broccoli has a naturally occurring self-similar pattern where each bud is made up of smaller buds that follow the same spiral structures. Remember that fractals appear everywhere in nature, mathematics, and even food. Whether it's a tree, a snowflake, or even broccoli, fractals shape the world around us in fascinating ways. That concludes our introduction to fractal geometry. We've explored what fractals are, how they work, and where we see them in the real world. In our next lesson, we take this journey even further, diving into how fractals are generated using mathematical formulas and computer algorithms. Get ready to unlock even deeper layers of this fascinating world. Up next, let's welcome Chanel Golante, who will take us on an insightful journey into the topic of world population. Stay curious and see you next time. I'm Chanel Queen Volante from BSIT1D. My topic is world population. The world population, a dynamic figure in mathematics, refers to the total number of humans on Earth, studied using population models, growth rates, and statistical analysis for trend understanding. The benefits of studying world population in mathematics. Studying world population in mathematics offers benefits such as understanding growth trends, resource allocation, environmental impact, economic planning, and disease and health management, aiding in predicting disease spread and healthcare demand. What will they learn in world population? Students will learn mathematical models, data interpretation, probability and statistics, global patterns, and sustainability concepts, including exponential and logistic population, growth models, and the relationship between population and resources. What is world population about? The topic world population in mathematics focuses on using mathematical models, statistical analysis, and data interpretation to understand population, growth, trends, and their impact on society. In the modern world population, studies help predict future growths, assess resource and needs, and analyze global challenges such as overpopulation, sustainability, and economic development. So this is the example of world population. Exponential growth model. One of the simplest mathematical models used to study population growth is exponential growth. Example, if a city has population of 3,045 and a growth rate of 2.3%, the population after 10 years can be calculated using the formula above. The world population is projected to reach 9.7 billion by 2050 and 10.4 billion by 20,000. With growth slowing down due to lower births, some regions are experiencing population declines due to low birth rates and aging populations. So this is another example of world population. Demographic transition. Mathematicians study the stages of demographic transition, pre-industrial, industrial, post-industrial, to understand how population growth and age structures change over time. Example, the transition from high birth and the death rates to low birth and the death rates is a key concept in demographic transition, which can be modeled mathematically.